Hi everyone. In this video, we are going to look at two parallel forces. This is mechanics, forces and motion. And this is our video number 5 under this topic. The problem here reads two forces, 2I plus 3J Newton and Pi plus Qj newtons. The forces are expressed in the vector form, act on a particle P. The resultant of the two forces is R. Given that R acts in a direction which is parallel to the vector I minus I plus 4J, show that 4P plus Q plus 11 equals 0. So many things here. So, first and foremost, we have our two forces, which are 2I plus 3J and Pi, we don't know what the value of P is, plus Qj, we don't know what the value of J is, expressed in Newton, yeah? Act on a particle, P. The resultant of the two forces is R. That is when you add these two forces, you get the resultant, which is given to us as R. But since we have unknowns here, PQ, so we're just going to get an equation in this case. But the interesting part is, it says given that R acts in a direction which is parallel to the vector I minus I plus 4J. So when do you say two vectors are parallel? If you say two vectors are parallel, what do you mean? If you have a vector like this, and you are told another vector is parallel to this one, so it could either be this or this, because parallel vectors, when you have vectors that are parallel, let me say two vectors that are parallel, it means one has a magnitude, one is a magnitude of the other. In other words, is one is bigger than the other, or is, then they are parallel, they are all going in the same direction, but one is a multiple of the other. If this vector, like now, for example, this was 4I plus 2J, this first one here, since this one is short, you can see this one is shorter than this, so this could be 2I plus J. So that tells you one is a multiple of the other. That is, if you multiply this by 2, you get 4I plus 2J. So this is a multiple of this. So in that case, you can say the two vectors are parallel. So if that is the case, in this problem, we are already told that the resultant of the two vectors is parallel to a vector. The resultant of the two forces is parallel to a vector here. Then let's see how we can solve this problem. So let's find the resultant of these two forces. You have them here. So resultant, which is 2I plus 3J plus Pi plus Qj. That is R, we are told. Since we are adding, let's bring like terms together, because we are adding. So now we have I and I, so this is 2 plus P. So 2 plus P, let me write this properly, I plus this big sign now, and you have again 3J plus QJ. So you have 3 plus QJ. So now we know the resultant of the forces, two forces. So, but the resultant of the force, we are told, given that R acts in a direction which is parallel to the vector I. So we are told that the resultant of this force R is parallel to the vector this. So which means we have a number to multiply to this for them to be parallel, as we have done in our previous demonstration. So if we say we don't know what that number is, we can call it, we have P and Q here, we can call it lambda, for example. So we now have lambda minus I plus 4j. This sign here, we don't know what the number is. But because these two forces are parallel, so it means one is a multiple of the other. So that multiple is what we have been represented by this. So now what do we have? If they are parallel, it means the I components must be equal to the I components of the resultant force. And the I component of this parallel, for the vector we are told is parallel to the forces, or to the resultants of the forces. The J component must also be equal to the J components of the resultants of those two forces. So if that is the case, therefore, we have 2 plus P, this is I, must be equal to minus lambda I, and then the J component, which is 3 plus Q, must be equal to the J component, which is 4, in this case, lambda 4. So if we say this is equation 1 and this is equation 2, they want us to show, in other words, prove that those equations are parallel. You must arrive at this equation. But when you look at the equation, sorry, there is no I here, we are equating. We have P and Q. There is no lambda. So it means, in this instance, we have to get rid of lambda. There is no lambda here. We have two equations. Normally we solve them simultaneously, but we have unknowns here. We have three unknowns, P, Q, lambda. So we don't go that way. Yeah? In the final equation we are given here, you can see there is no lambda. But in our two equations we have lambda, the multiple of one of the vectors. So let's get rid of lambda. Quick way to get rid of lambda is to multiply equation 1 by 4, because we have 4 here. If we multiply equation 1 by 4, we add the two equations, minus 4 plus 4 will cancel. So equation 1 by 4, multiply equation 1, multiply equation 1 by 4. So now equation 1 becomes, if you multiply throughout equation 1 by 4, it will become 8 plus 4p equals minus 4 lambda. If we call this now equation 3, and you leave equation 2 as it is, so it's 3 plus q equals 4 lambda. This is still our equation 2. Now let's add the two equations. 3 plus 8 plus 3, you get 11 here. 4p plus q, you get 4p plus q, it doesn't change, equals to minus 4 plus 4, or 4 minus 4, 0. So we got this, So you write like this. This is a proof. Thank you for watching. Bye bye.